follow the rules of the test points. If you follow the rules of the test points, you're always checking to see if it goes to the origin, figure out which side you shade. Remember, you always shade towards the truth. And then after that, we have to remember how to do quick graphs. Sometimes quick graphing is a very, very easy way of doing things. Don't forget your rules when you multiply or divide by negatives. You're moving stuff around to flip your inequalities. And go from there. Okay? So in this first equation, what I'm going to do is just kind of set up both of these guys and solve for y. This is, when we're graphing these inequalities, these systems like this, it's not always a bad idea to have more than one color. Sometimes it's helpful for students to see the overlap if you've got two colors. Whether that's a pen and a pencil or just a couple of different ones. So I get negative y less than or equal to negative 3x plus 2. Divide out. Remember, flip the sign. And I wind up with that. Y is greater than or equal to 3x minus 2. Start your plot. Start your plot at negative 2 like you would normally. Walk your slope of 3. Down 3, right 1 is the opposite direction. And then go through the questions again. Is that going to be a solid or a dotted line? Solid. So I just draw a solid line. Did that go through the origin?
The outside?
Nope. So is 0 minus 0 smaller than 2? Remember, always test back to the original.
Yeah.
You sure about that?
Yep.
You sure?
Yeah.
Yeah? Okay. I agree. Which means it's a true statement, so I shade above. Okay? And now I just go to the other line. The other line is 2x plus y is less than or equal to 2. So that means it's y is less than or equal to negative 2x plus 2. All I did was just move that over. Yes, sir? Here? I divided out by the negative.
Oh, that would pretty handy dandy.
You see, there's.
Oh, I can't even show you.
It's okay. It's Monday. Is this going to be a solid or a dotted line again?
That's solid. Stop. What is it better stop? It's solid.
Did it go through the origin? Is 0 plus 0 smaller than 2?
Yeah.
And then what happens here, it's a little bit more difficult to see. If I can lighten this. See how there's an overlap there? The blue and the black? And what happens now is that any point that I pick in this region, any point in this double shaded region would be a true statement for both inequalities.
Katie's back.
Back.
Is she back? Yes, she's back. Yes, she's back. Great, I'll have that song stuff. And that's what we're doing. All it is just multiple inequalities on one piece of the graph paper, and we're trying to figure out where they overlap their shading. Okay? Let's try some more.
I'm gonna have to actually get my graph and put it on the board there.
Good. Lighten this up a little bit. All right. Once again, in in this example here, I've got y is greater than or equal to negative 3x minus 1. I don't have to move anything around in that equation, or excuse me, that inequality at all, because it's already written into that slope-intercept form. So I just go to my intercept and I walk my slope. My intercept is negative 1. My slope is negative 3, so down 3, right 1. Down 3, right 1. Opposite of down and right is up and left. And will this one be a solid or a dotted line?
Solid.
It's solid again.
Probably solid.
Can I use the origin again here for my test point? Yeah. All right, so is 0 greater than or equal to 0 minus 1? Is 0 bigger than negative 1?
Yeah.
Yes, it is. So it is true on this side. Okay? Now I go to the other graph. The other graph is y is less than x plus 2. Slope of 1, y-intercept of 2. Is that going to be a solid or a dotted line? It's dotted, and I'm just going to do this since I filled in so many dots there. I can just do that.
I do that too.
Is 0 smaller than 0 plus 2?
Yeah. Pretty sure.
It is also true, so I shade towards 0. And there's my overlap in that region. And once again, all that means is that anything I pick from this region, any part that I pick in this region becomes a true statement for both inequalities. Any of those ordered pairs will work. What this shading of inequalities allows us to be able to do is it does give us boundaries. We are going to be working more and more and more with this bounded region style problem, especially tomorrow. As you can see on the board, I've already written up kind of where we're at this week. We're doing systems of the inequalities today. Tomorrow we start linear programming of 3.4. On Wednesday and Thursday will be the word problem portion of it, and that word problem portion might still even go into Friday. All right, it's a very time consuming to get through some of those problems. I do not foresee us quizzing in this chapter because there's only 5 sections. So our test in this chapter will probably be next Tuesday or Wednesday already. Once we get out of here, because 3.6 is really easy. All right, just so you guys know where we're at. So try this one. Take a second, try that one.
Yeah.
To be honest with you, this is about as crazy of any of the intercepts you'll ever see from me is a half. There's no other reason to do any of the other ones. I don't think it's that big of a deal. If we can graph a half, we'll be fine. So it's negative 1.5. And it's just a matter of guesstimating the best you can where the halfways are. Was this one going to be a solid or a dotted line? Do you remember?
Solid. I thought that was solid.
Yeah, that one's a solid. And then we test it through the origin. Oops. Is 0 minus 0 smaller than 3?
Yeah.
Oops.
Down a little bit more. Way good. Way good.
And the other one starts at negative 4, goes up by 3. you'll wait. All right. And then this one's a dotted. Is 0 bigger than -4?
Yeah. I think so.
And there's your double shaded region.
Double shaded.
Not so scary?
Not so scary if your name is terrorist.
Alright. Uh-oh, now what happens?
What is
What is this? Mr. Murphy trying to kill us.
Try this without a... I want to try without a graph. We're going to use magic here. X is greater than 0, Y is greater than 0. Where does that occur?
On the axis.
What quadrant is this problem?
No!
This is the first quadrant.
No.
Does everybody agree that's occurring in the first quadrant? X is greater than 0 is going this direction. Y is greater than 0 is going this direction. Do we agree?
Yeah.
Now I get it.
Okay.
Just saying that.
Yeah, that's what I was wondering too.
Okay. Now use quick graphs. What's your x-intercept?
Can't do this in your head, so X.
6 and
6,
8.
8. Thank you. So I have an x-intercept at 6 and a y-intercept at 8. It's a solid line. Did that go through the origin? Is 0 plus 0 smaller than 24?
Yeah.
So what we have is this shaded boundary.
Oh, that's crazy. I don't understand.
What we've done now is you guys have just created a shaded region that has specific boundaries. You also can figure out the 3 sets of ordered pairs where the intersections occur. What are your ordered pairs at your intercepts?
Don't touch me.
What's the ordered pair here?
6,
6-0.
6, 0.
God, man.
And then this one would be 0, 8. And what's this one?
0.
Yes, sir.
I guess I'm just a little confused on the whole y is greater than x is greater than 0.
Okay.
Those are lines,
Mhm.
of course, and all it's doing is creating a boundary.
I understand.
Were the three, like, when you got the
What
three
happened?
areas, when they
What happens here, if you think about numbers that are x is greater than 0, is all the numbers going to the right here, correct? All these numbers here. Y is greater than 0
Yeah.
is all this.
Right.
Right away, where do those two intersect?
Number 1.
That's why I didn't draw anything else.
So that's you're just showing us that's where they meet.
That's where they meet.
Oh, so we could have shaded everything else, but it's not necessary.
Correct. So that's why I wanted you to start to recognize sometimes you're looking at specific quadrants. Yes, ma'am.
Okay, I get it now.
Yeah, it's where everything overlaps. Because the third inequality was 4x plus 3y is less than or equal to 24. So when I drew my line, it was here. I had to test 0, 0 to see which way it was shading, and it was shading in this direction. And since it was bounded, if you look at this on the grand scheme, if we graph this, if you look at this through the long way of doing it, if we drew this out on graph paper, oops, this was shading in this way. It was numbers going here, and then numbers coming in here.
The lines are the
I like where it's at.
same lines that we got.
Yeah, and what I did is by recognizing right away that I did not have to worry about the rest of the quadrants, I just worried about drawing in here. So we have just an intersected point.
It's just not shown.
Correct. For $1 million, this is point A and this is point B. What's the distance of AB?
No.
6.3.
For $1 million.
6.3 units.
7.
Oh, it's the distance formula, silly.
No,
Wait,
not.
I'm not. Oh wait, no.
Distance from A to B.
What is it?
Time out. Get a ruler, Willis. Willis, get a ruler. Willis, get a ruler.
Thank you. 10, you get $1 million.
Why is it 10?
It's a triple knucklehead.
Oh, like, oh my god.
It makes a right angle there at the XY right there. Ah, your geometry teacher is very upset with you.
Mr. Seb said not to assume because there was no angle there.
Yeah, we gotta do a proof on it.
You gotta prove it.
We gotta do a 2-column proof, 6 steps.
I don't know what that means.
No one's.
Oh, here's the right angle.
Try another one. Try another bounded region. That's not really bounded that badly, though.
Brian, don't start now.
Take your shoes off.
No, Brian.
Yo. Remember, when you're sitting here right off the bat, x is greater than or equal to 0. Remember, the x values being greater than or equal to 0 starts this direction. It's all of this going this way. All the numbers of x are larger going this direction. Okay? And now you start plotting the rest of it. -1, slope of 2.
You know that one?
It's a dotted line, and then I just check it. Is 0 bigger than -1? Yes. So it's going this way. So we wind up with a little bit of the overlap right in this area. Now the other one's 2x plus 3. Same thing, it's a dotted line. They're parallel to one another. Is 0 bigger than 3?
No.
No, so it's still true coming up this way. So this is going to be a little bit trickier to see. You're looking at this area, this kind of region in here. You're looking at that very little tip spot there, because you're stopped by the x-axis, or excuse me, the y-axis. You're stopped here because it's got to be x is greater than 0, and then the dotted line coming up to it was also part of the shared area. So you get this very little space there.
That's only.
It's very easy to get lost in your shading if you're not careful with the way you draw it.
That one, sort of expand.
Okay.
That's right, because
Let me give you some problems.
Zero isn't it?
Yeah.
Zero is greater than negative. That's true.
Let's see. I want you guys to start with, what number was it? It was 36 through 44. And
We don't need a notebook, right?
no, this you just saw on graph paper. And then 48 through 50.
What was it again?
Yeah.